Right, so now we're going to move on to surds. So what a surd is any n, or which is a non-square value. If we square root it, then it's called a surd. So for example, the square root of 10. 10 is not a square value, right? So we have to, if we were to square root it, then we'll get a value which would be a long decimal place, a never-ending decimal place. And so rather than that, we write it as a root 10 and we call it a surd. It's just a cleaner way of writing non-squared numbers when we square root it. Right, so with that, we can actually find or use a couple of characteristics or rules. So if we have two values multiplied together and they're both rooted, then we can combine them up into x times y. So for example, if I have root 2 times by root 3, they are both surds, right? This is equivalent to root 2 times 3, so I can say it's equal to root 6. Same thing for dividing. If I have root 10 divided by root 2, then I can say it's root 10 over 2, which is the same thing as square root of 5. Okay, so these are just some of the rules when it comes to surds. Okay, so from here, now we can just go about just manipulating surds. So let's say we have the square root of 24. 24 is not a square number, so it's a surd, right? But I can simplify this a bit. So the way we simplify is maybe think of a number or two numbers. When we multiply them together, you get 24. But one of these numbers has to be a square number. So for example, I can say 4 times 6 is 24, and then 4 is a square number, right? Which I can split up into root 4 times by root 6, and root 4 is 2, so this will be just 2 root 6 like this. It's just a simpler way of writing surds, and if you put root 24 into calculator, your calculator will already simplify it to you and give it to you in terms of 2 root 6. Other examples are maybe like root 44. Once again, I can say it's square root of 4 times 11. Square root of 4 is 2, so I can rewrite this as 2 root 11 like this. If we look at root 35, I can say, well, there's no two numbers where one of them is a square number, right? Because I can have maybe 7 times 5, but neither of these are square numbers. So this will not simplify, and this will just remain as root 35, like so. We can also have maybe the square root of 175 plus square root of 68. Let's go minus 2 root 28. So stuff like this we can also simplify. So looking at each term separately, so root 175 I can say it's equivalent to 7 times 25 plus root 68 is 7 times 9 minus 2, 7 times 4. So simplifying each term separately first, so this first term would be 5 root 7 plus 3 root 7 and then minus 4 root 7. Now we can add and subtract them. So 5 plus 3 minus 4, so 8 minus 4 is 4 root 7 like this. So you can sum and subtract them if they have the same square root. If they're different square roots, then we can't sum them or subtract them at all. Okay. We can also expand brackets. So let's say we have root 2 times 4 plus root 7. Expanding bracket is the same as we've learned, just make sure you multiply to each term. So the first term will be 4 root 2. Plus the second term will be root 2 times 7, so it would be 4 root 2 plus root 14, like so. If we have two brackets, maybe we have 2 minus root 3 multiplied by 4 plus root 3, root 2, let's go for. It's the same thing as expanding brackets, just make sure you multiply to each term. So 2 times 4 is 8, 2 times this is plus 2 root 2, minus root 3 times 4 is minus 4 root 3, and minus root 3 times minus root 2 is minus root 6, like so. And we can just simplify or leave it like this. Let's go for maybe another example. 4 plus root 5 multiplied by 2 plus root 5. So same thing, just multiply each term in each bracket. So 4 times 2 is 8. 4 times root 5 is plus 4 root 5. Root 5 times 2 is plus 2 root 5. And root 5 times root 5 is just root 25, which is just 5. In this case, we can simplify because the square roots are the same, right? So 8 plus 5 is 13 plus 6 root 5, like this. Let's just try one final one. So let's say maybe 5 minus root 3 and 5 plus root 3. So same thing, 5 times 5 is 25. 5 times root 3 is plus 5 root 3. Minus root 3 plus 5 is plus 5 root 3, and minus root 3 times root 3 is minus 3, like this. And as you should notice is, this would be negative, sorry. So as you can see, these two will cancel out, and you're just left with 25 minus 3, which is equal to 22. Now this specific one is going to be very useful in the next video when we're going to be looking at rationalizing denominators, because we managed to get rid of any surds when we multiply in this kind of form.